Hi, this is Claire, and I'm going to show you an application problem using Pythagoras. So we have a situation here where we have a wall, and here's the ground, and we have a 9-metre ladder. And I've drawn this simply showing you that it forms a triangle. It's a right-angled triangle because the ground and the wall meet at 90 degrees. Across from the 90-degree angle, we have the hypotenuse. And we want to know how high up the wall the ladder reaches. So we can set up the Pythagoras theorem here, being careful to say the hypotenuse squared equals 6 squared plus, and let this be equal to a, plus a squared. So we need to find the value of a. So let's square 9, which is 81, and 6 squared is 36, plus a squared. So we're going to use some algebra now, and we need to subtract 36 from both sides. So 81 minus 36 equals a squared. So picking up our calculator, and this is a different style of calculator. 81 subtract 36 equals 45. Now, 45 is not a perfect square. So we're going to get a decimal answer. We need to find the square root of 45 here. In fact, we're finding the square root of both sides. So the square root of a squared is a, and the square root of 45 we write as root 45. This is the most exact answer to this problem because we're going to get a decimal approximation when we find the square root. So it's just going to be a decimal that we need to round. So using your square root button, clear the calculator. Square root of 45 is 6.7082, and it continues on forever. So this is an irrational number. It has no recurring pattern, and we're going to round it to one decimal place. So you look at the number next to the 7 and it's 0. So 0 is well less than 5, so we can drop that section of the number off and just write 6.7. So A is approximately equal to 6.7 metres. Right, just say this person needs to reach a bit further up the wall because they might need to paint right up to the bottom of a window. So they decide to move the ladder in closer to the wall. So let's draw this again. We'll draw the wall. They decide to move their ladder 3.5 metres from the wall. So here's the ground, and we'll measure 3.5 metres. You don't have to draw this to scale, but this is drawn to scale. So the 9-metre ladder reaches much further up the wall, as you can see, right up to here. Okay, so that's 9 metres. And now we want to know how much further it's reached up the wall. So again, it's a right-angled triangle here. And across from the right-angled triangle is the hypotenuse. And we'll call this A. So using the same process, 9 squared equals 3.5 in brackets all squared plus a squared. We use a bracket around a decimal just to show you that the whole thing is squared. So 81 equals, well, I don't know 3.5 squared, so I definitely need to use my calculator. So clear, and 3.5 squared equals 12.25. So it equals 12.25 plus a squared. So let's Subtract 12.25 from both sides to get a squared by itself. 81 minus 12.25 equals a squared. Using the calculator again. Clear. 81 take 12.25 equals 68.75. So a squared equals 68.75. We're definitely going to get a decimal for this one. So a is going to be the square root of 68.75. Using the calculator again, square root 68, whoops, backspace, I'll just clear that again. Square root 68.75, and you get 8.29156. So this again has no recurring pattern in the decimal places, so it's an irrational number. So 8.29 rounded to one decimal place. Look at the digit right after 2, it's 9, and that's very nearly the next 10. So you can round that 2 up to a 3. So that will be 8.3. So A is approximately equal to 8.3. So it reached much further up the wall. So how much further did it reach? You could well get asked that. So we can easily solve that with subtraction. So you would write 8.3 take 6.7. And on your calculator, you could solve this, or you could just easily do this yourself. 8.3 subtract 6.7 is 1.6. So 1.6 metres further it reached up the wall. So you can solve lots of practical problems using Pythagoras, and we'll talk about more of these as the week progresses. Bye for now.